Pretty easy? Didn't we write about 2/3 of this last class?
Yeah, pretty much.
Actually, not even 2/3. 9/10 of this last class?
I don't remember.
Who's supposed to lose by 8? All right. So let's write this down here. So who thinks they got this right? What's up? What do I call this? Add factorials to be a lambda that takes in num1, num2, 2 parameters. Okay, and then we're going to create a letrec. And inside the letrec, we're going to define fact actually, hold on a second. We're going to define fact to be a lambda that takes in a single parameter, ask the question if equal x1, return 1, else multiply x times fact of minus x1. Okay, so that is our parameter list for the letrec. And then inside here we'll say plus fact num1, fact num2. So there's add factorials 5 and 4. So what does a letrec do? Let's start off with what does a let do? A let creates a local environment, right? What does let star do? Same thing as a let does, except it allows us to define variables in terms of variables that have already been defined inside the let. What does a let rec do? It allows us to call things recursively. Actually, maybe more importantly to that, it allows us to define things in terms of themselves. So 99.9% of the time that means call things recursively. I can't think of what that extra 0.1 is, but I'm just covering my butt. Make sense? So what did I do? I wrote a normal lambda that takes in 2 parameters, created my letrec. My letrec defines exactly one variable. That variable is called fact. Call it whatever you want. And its value is a lambda expression that takes in a single parameter and calculates factorial. If that one parameter is 1, return 1. Otherwise, multiply whatever it is times the factorial of whatever it is minus 1. And then the body of the letrec is this guy right here, which says add the factorial of our first number to the factorial of our second number. Remember, variables resolve to their most local definition, right? So num1, first, what's the most local variable environment to num1? The most local variable environment is the one defined by the letrec. Do we find num1 defined in there? We do not, so we need to jump to 1 higher. Is num1 defined in the variable environment defined by our lambda? It is. So that's where we resolve num1 to whatever value we passed in. In our example here, it would be 5. Similarly, num2 is 4. But now fact, that's a variable that's bound by our most local. Now, based on our Simon language, what kind of expression is that? Anybody should know this. It should be Simon. It's your language. What kind of expression is what I have highlighted there? I know Jake knows the answer because I just saw him say it silently. He silently conveyed the... So don't make eye contact with Jake. You might get the answer. Here, I'll even scroll up to give you choices. Oh man, that scrolled fast. It's like a turbo scroll. Okay. Yeah, well, I'll just show you. I'll just show you the part of parse Simon that's important. It's this part up here. Go ahead, Skippy.
Is it an expression?
A what expression?
An app expression.
App expression. It is an app expression. I thought you just said, is it an expression? I was about ready to throw Simon at you.
I want to see that.
Yeah.
I think I can lift Simon up. My back might be screwed afterwards, but I could lift Simon and like probably kind of heave him in like a direction. I doubt I could like clear tables. I don't think I have like I don't know if anybody, can any human being throw somebody Simon's size like a distance like that?
Yeah. So does someone.
Really? That far of a distance from here to Skippy?
Yeah.
Probably.
Yeah.
Yeah.
I mean, I can see like throwing an infant that far.
Yeah.
Now the thing is, this isn't even This isn't even the most messed up conversation I've had in class so far today. This morning we were talking about Rise, Son of Rome, and I invented a new death move. Apparently, somebody said there's a move already built into the game where you can like do the side swipe and break somebody's arm when the bone's like exposed, and then cut their leg off. But I have the follow-through move. The third thing is you rip off their mostly broken arm and stab them up through the bottom of their neck, through the top of their head with their own bone. So the whole class decided that I should be the one coming up with I should be like the one giving them ideas for their game.
How did you play that?
Huh?
I thought that wasn't out yet.
It comes with Xbox One.
I thought that wasn't out yet.
It's not. There's like, you know, gameplay YouTube videos. Good news is all of my Xbox Ones have shipped and are arriving tomorrow.
Oh, how many?
All? You're the reason other people are going to be waiting in line somewhere.
And the thing is,
You
I
got
didn't
100 Xbox
try to pre-order any of them. I got 2. One of them I got by accident because one of my students messaged me in this class, right? And I pre-ordered it during this class. And then the other morning, Nick Ashenden messaged me saying Amazon had pre-orders at 7 a.m. We had like 10 of them, and I have one, single-click checkout, so I got one of those too.
So what are you going to keep both of them?
No, actually, I sold the Amazon one on eBay before I even got the email from Amazon confirming the purchase.
Did you
The
make
person,
money on it?
$200. And I have my other one listed on eBay to sell, but it's like listed at a price that I would be willing to sell it for.
So you're not going to keep any of them?
No, I think I will likely keep that one. Like I would like to keep that one, the one that comes with Rise, Son of Rome. But I have it priced at a number that I would be willing to take and wait for. No, no, it's $1,000. Something I paid $730 for. And then that covers my PS4.
What is the PS4 starting for? Price what?
$400 retail. Well, yeah, that's the retail box. It doesn't come with none of the retails come with the camera. Well, there's probably bundles that do. I'm
You know
guessing.
what the hard drive size of the retail one is?
Oh, I don't know.
Both 500 gig.
There you go. 500 gig.
Solid state or no?
We just found out about.
It's actually a laptop hard drive.
It's crap.
That doesn't matter. Even if I would have done this Tuesday, there's not one title with the second.
All right. So does this make sense? How we used the let rec for that? I heard a no. Was there a no? There may have been a no. If there was a no, would anybody admit to it? Because what we should do now is have a second quiz where I delete this and tell you to write it again.
No, we should not do that.
Let me go into a little more detail with this, if you will. What I'm going to do here is I'm going to define another function called fact2. And fact2 is going to be a lambda that takes a single parameter and then asks a question. If equal x1, return 1. Otherwise, return x times fact2 of minus x1. So if I were to write a helper function version of add factorial, so we'll say define add factorials 2, and this guy is a lambda that takes in a num1 and a num2. And what does he do? He returns fact2 of num1, fact2 of num2. So add factorials just takes in two parameters and returns the sum of calling a helper function on num1 and a helper function on num2, where that helper function is our factorial function, which I called fact2. What we did here with our quiz version of add factorials is rather than having a helper function, I created a local environment. And inside that local environment, I defined a variable named fact. And I gave it the value of a lambda. And you'll find that that code is identical to this code right here. That makes sense? Just wrote a lambda procedure. What's a lambda? If you had to give a concise definition of a lambda, what would you say?
Undefined procedure.
Try very, 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 very close, but let's try again. An unnamed procedure. It's definitely defined. And I suppose, I don't think you were thinking about this the wrong way, but you could say it's an undefined procedure from the perspective of that we did not define a variable to hold it. But the more correct answer is that a lambda is a procedure without a name. Does that make sense? So a lambda is a value for a procedure. So here's my value. That guy's my value, and here's my variable name. So this creates a local environment with a single variable defined in it called fact, whose value is a lambda procedure. And then inside that local environment, so notice that right here, I am inside of the body, the local environment that's wrapped by this let rec. So anything that happens inside the shaded area here is occurring within the local environment defined by the let rec, which is governed by this variable environment as well as the more global variable environment there, as well as the even more global variable environment up here. Something like that. Okay? That would also be an even more global variable. So rather than having all these helper functions, I can create a local version of it. So now here's the $1 million question. Well, it's actually probably like a $14.75 question. You'll get it wrong. Which is better between these two? Would you prefer to write it? Well, I'm going to ask you to tell me which way to write it, but I'm also asking you to defend why. Should you write it this way, as two separate functions with a helper function, or should you write it this way? And why? Beaker.
Depends on what you want to do. I'd say the second way, because if later you want to maybe add pre-factorial.
This is the second way?
No, the number 2.
Okay, so this is number 1. So the second way we wrote. The first way is represented here, right? So that you're saying this guy.
Right.
You're saying write it that way. Okay? Why?
Because let's say later you want to add 3 factorials. You don't have to recreate the whole add factorials thing to add 3. You can just use that back 2 and just add 3 of the numbers altogether.
Okay. So Beaker wants to use this one, and the cleaner way of saying what you just said is that we might want to take factorials of things later. So might as well give ourselves a single function that just solves the factorial problem. Right? Okay, I don't have a problem with that. Anybody want to argue for this guy? Why should we use that guy? Go ahead.
Well, devil's advocate, if we just want to use it once, then what's the point of writing helper function?
Okay.
It just encapsulates it all in one.
Yeah. Clearly, if we're just going to use it once, then writing it all in one encapsulated thing makes sense. You could probably make a reasonable argument for that for one-off type problems, solutions to problems, but factorial might be something that is generally applicable. Okay, so that might be something that you would want to have that ability be reusable later on. Where if you're just doing something quick and dirty, something that you only need in this one exact little place, why create extra fluff outside of the function that's going to be hard for us to follow because we're already having all these helper functions in here, right? So why not just have it all self-contained? So we use it and we're done. That makes sense? So I think in this particular case, Beaker's argument wins because factorial is not a generic type solution or not a one and done type solution. It's something that we might potentially want to use again later. But in this case, we didn't. We only used it once, and so either one is acceptable. But this let us practice letrec. That would have also been an acceptable answer. Like, which of these should we do? Well, this one, because it lets us practice letrec, and we all need practices on letrec, right? How many of you got the quiz right? 3 people? 2.5 people? Thor? Nothing? Close?
No sense, I guess.
The who?
No way.
No. Were you here last class?
No.
Weren't the rest of you here last class? Huh? Did we basically write this last class? Yeah, I mean, we wrote, everything we see right there was written last class. I think instead of adding factorial, I think we just called factorial on something, didn't we?
Yeah, just on one variable.
We called factorial on one value. So all I asked you to do is add. I'll tell you what, you guys are going to be the end of me. At least Carrie had an excuse. She was saving people's lives by giving blood, right? How much do they take? A couple gallons?
At least you have a couple gallons.
You get 1.5.
Yeah, I think
Like a couple
we have,
gallons or something.
no, I don't think you have 8 quarts.
Is it 5 liters?
I'm not much sure what it is.
8 donations is 1 gallon. That's what I was at.
You were at what?
I was at 8, which was 1 gallon.
So you gave a gallon of blood.
Well, not today.
Oh, you did. You said, I got you. You donated 8 times. So you gave 1/8 of a gallon.
No.
Today you gave 1/8 of a gallon, assuming each donation was equivalent. And this is why the
6 quarts.
6 quarts.
An average adult body has.
I wonder if I have more blood than the average, or just the same amount of blood,
You have to.
but less, but more interstate for it.
Otherwise, like super huge people just have like a drop, a dribble of blood.
Well, I mean, I think that's why, people who are really heavy have some cardiovascular problems. I don't think they quite have enough juice to go around.
And then like someone that's like a midget would just like explode.
that heart's got to really. I mean, that heart's pumping into a lot of like extra capillaries and stuff. All right. I like that coffee. Tastes tastes weird for some reason. It's the cafeteria coffee. It doesn't taste like it usually does. It tastes better. More bestest. All right. So this all makes sense? The let rec crap? Okay. Now, what if we'd like to write this in Simon? Now, remember, so far, let me just delete a bunch of crap here.
Oh my god.
That was like trivial code, people.
Now we can parse Simon.
What's up?
Now we delete parse Simon now.
Tell you guys to write that for a quiz. I've been trying to give you guys the benefit of the doubt. I tried to think back to like when I first did this stuff, but I think I was really good at it then too.
That's just suck.
Well, Jake's really good at it, right? I was probably about like Jake is. I mean, any mistake you make, you immediately knew you made the mistake. It's like oops, right? Huh? Yeah, that's it. I mean, it's like trivial stuff. And did Jake look that bright? See, he slept through last class. He got the quiz right. You guys are embarrassments.
But I don't think you can imagine like stabbing people with their own bones.
I know, which makes me even more better. Because I can do this plus write a video game in my head. Would you ever imagine that? My wife says I have
You
issues.
should ask Joey sometime about our Civil War killer. You know, something like that. In the context of the Civil War.
Yeah. I think we decided this morning, though, that any video game that I was like part of for like talking about the way to like, kill people probably could not be released to the general public, outside of the Iron Curtain. This is all right. So, as a reminder, remember, shut up. So here, let me quickly write a short version of our let from last time. So let's say that's SE7. Shut up! You're not going to do your homework. At least don't babble in the front row. Sit in the back with Skippy. They're not getting anything out of it anyways. Dane's like... All right. So here's some legal Simon code where we have a let expression. That let expression, if you remember from last time, here's parse Simon. Here's our let. Our let creates a var def expression where it has a list, and that list contains two things. It contains the variable. It basically contains the variable environment, the new variable environment we created, as well as whatever parse Simon says the body is. That makes sense? So for this guy, the Bazel code equivalent of this guy is going to be define Bazel BSE7. So the Bazel BCSE7, Bazel code Simon E7, addition KK. Thanks. All right. So that guy, it's going to come out to, what do we call it? Do we call it a var def expression? Yep, var def expression. So this is going to be var def expression. Then a list. First element of that list is going to be that guy. Second element of that list will be parse Simon on this A, which is a var expression, right? So the second element of that list will be this. Is it just var exp? Var def exp like that? No R, okay. Is it just like that? So that's what it'll return. Kick it down a line there for you. So parse Simon on this guy should give us this guy. That's our Basel code equivalent. Let me just confirm real quick that var expression creates a list with the expression. Yeah, that's right. So this is what it'll look like. This is the Basel code equivalent of the Simon code. Make sense? Okay. Now, if we run this now using our apply expression, this guy, so I'm going to call apply, is it expr? Yep. First parameter it takes is Basel code. So here's, I probably should have named that a little bit cleaner variable. There we go. That's the first parameter. Second parameter is the empty environment, because it needs to take in an environment to work with. So we're going to start off by sending it a global environment that has nothing in it to get the ball rolling. And what should the output of this be? What should the output of this Simon program be? 5. Is this correct? My Basel code has to be incorrect, because I think if we do parse Simon, no, it's parse Simon of SE7, I think this works. Yeah. So my Basel code must be a little bit off here. Is it this guy? No, like that. So my hand-created Basel code was a little off. Nope. Let's just see what it looks like. So we're gonna say parse Simon SE7. That should give us the Basel code equivalent, and I'll just cut this line real quick. So let's see how this guy differs from what we hand wrote. Hello. So it's going to create a list, var-def expression. Let me scroll down to this guy. So list, var-def expression, so far so good, followed by a list containing the list A5 and the list B7. Oh, it's treating those as variables. Followed by a list that's like that. Okay. This is the problem. Those need to be like that. Otherwise, it's treating them as variables. A list containing two. I got it. What we had originally. This guy. That. All right. So now we should be able to call this guy, and it should give us the 5. That. Still doing it wrong?
I think you need the apostrophe before the variable def expression and variable expression.
These guys?
Yeah.
But then I'm going to throw my extra list back in here.
Right.
See how much better scheme is? We can't write it by hand. We can write a function that creates it. All right, let me...
Or you take out all
Hold on a second here. So let's do parse Simon SE7. Get rid of this again. We'll just walk through this. So we have a list whose first element is var def expression. This guy. Whose second element is a list. Whose third element is a to list. So it should be like this. Whose fourth element is a to list. Then we have our closing list. Then we have a list containing var expression. Like that. So that should be what it looks like.
I don't think there should be any single quotes inside of
Yeah, this whole thing is quoted. I think that's what it looks like. What's up? I don't think that this thing had that. So we have a list. Here's the outer list. Then we have var def expression. Then we have a list containing two to lists. Here's a list containing a to list and another to list.
No, it's a list of lists.
Oh, I didn't see this list. Okay. That guy. Now we're happy? Yes, we are. Okay. All right. Now understand, this was nothing wrong with their code. It was the coders. So we couldn't translate our Simon into Basil without Scheme. That's how much we need Scheme. Scheme is better than we are. Okay. So I'm just going to get rid of that now because we don't need it. Clearly, we're not good at it. Okay. So the output of this was a 5, correct? If I say parse Simon SE7, we got our 5. Why did we get our 5 in the Simon language? What do you think, Brandon? Do you know the question? Go ahead, Skippy.
Because A resolves to its most local definition, which would be 5.
Okay, which would be 5. And we actually wrote the language that bound it to 5. This isn't Scheme. We wrote this. Okay, this is what we did last class. We defined what a let expression is in Simon. We added to our empty environment this new scope. And then we resolved A inside of our environment, which has the most local definition right here, which is A5. Now, let's say that we wanted to support something like that. What kind of expression is this? It's an app expression. Well, it's not an add expression. We don't have anything called an add expression up here.
That's our homework.
Huh? Oh, your homework is to write an add expression. Perfect. See, we're on the same page. Okay, so that's an add expression. So we're supposed to add an add expression up here. So now we're doing your homework assignment. Okay. So, if we had something where the car of our expression was a plus sign, right? If that's true, then what are we going to do? We're going to create a list whose first element is an add exp and followed by, actually, how do I usually do this? Okay. Yep. Just want to keep our stuff. A list whose first element is the catter of our expression and whose second element is the of our expression. Right? So that's our add expression. That's what you needed to, for your homework, that's what you were to add to parse Simon. So that will convert a Simon add expression into Bazel code. Let's go see what that might look like. So we'll create a define SE. Well, actually, here we already have SE7. So we'll see this guy in action. Get rid of the supply expression here real quick, and we will just call parse Simon on SE7, and we should see an add expression in there now. So here's our add expression. That's the body of that var def expression. Make sense? Okay. Still not right.
Can you go back up to the code?
Are you going to tell me what's wrong with it? Okay. All right. This is what we just added that's not done. Is that a hand from Carrie? Huh? Yeah? No?
Don't you need to get the parse Simon?
Of these two, right? Yep. So you notice down here, we're just getting A and B. These really are var expressions, right? So we need to call parse Simon on those guys. Hello. I wish I hadn't done that. Okay, there we go. That makes sense? So we called parse Simon on the two parameters of our add. What we were doing before is when we saw plus AB, we were saying, oh, I see the plus sign, it's an add expression. So create an add expression, and here's the two parameters, A and B. But A is actually a var expression, and B is actually a var expression. Yet we didn't treat them as that before. But now when we run this, we'll have two var expressions in there. Make sense? Okay. So that works. But now we need to be able to handle actually applying this. Now, were you supposed to write apply to or just write this? Huh?
Just add. Just add.
You had to update the flag.
Okay, so we had to write this and make it work. Okay. So we're going to go to apply expression. That's what we look at if we're looking at a var def expression. Otherwise, what if the car of Basil is an add exp? If that's what we're looking at, what are we going to do? That's what we're looking at. We're going to add apply expression, passing it this guy, the list ref of bucket 1, and passing it our environment, right? And then we're going to call apply expression, passing it. Actually, this should be 0, this should be 1. It actually wouldn't have mattered in this particular case since we're adding two numbers, but and passing it the environment. So list ref, the catter of our Bazel code. So this is the Bazel code. The cooter of that is going to be a list containing all of this. The catter of that will be, the cooter is a list containing a list. The car of that would be this list. List ref of that would be this guy. That's bucket 0. That's bucket 1. Make sense? That's what I'm grabbing right here. So that list ref right there is saying I want to call apply expression on this guy, given the current environment, and then I want to apply expression on that guy, given the current environment. And I want to add those two guys together. Make sense? Okay, then to test that, here's our let expression with our plus A and B. And we're going to call apply expression, passing it parse Simon of that as well as the empty E and V. And we get 12. 7 plus 5. Make sense? Now we got a language that can do some math. But at this point, we can only do a little bit of math. We can only do plus expressions. Now, we can do minus, we can do times. Now, why don't we create a helper function for doing math-based expressions? That way, we don't have to have a bunch of different, I guess, arms, if you will, for add. You know, we don't need to have an add expression and a subtract expression and a multiply expression and a divide expression. Although those aren't maybe that big of a deal. Yeah, it is. All right, so we're going to go up here. We're going to update our parse Simon to no longer create an add expression. Now we want it to create a math expression. All right? So we're going to create a math expression if we're looking at a plus sign or a minus sign or a multiplication sign or a division sign. Does that make sense? All right. How do I check here to see if those are all included? I want to know if something is if the car of our expression is a plus sign, or the car of our expression is a minus sign, or the car of our expression is a multiplication sign, or the car of our expression is a division sign, or possibly in the future, the car of our expression is the percent sign for modulus, so on and so forth. I could put a whole bunch of ors in here, couldn't I? But couldn't I also write a function? Do I make that a helper function, or do I do that as a let? The cool kids would use a let. Question is, are we going to need to determine if something is inside of a list more than once? Are we going to need to determine if we're looking at a symbol is either a plus sign, a minus sign, a multiplication sign, or a division sign? Are we going to need that more than one time? For our intents and purposes, let's assume no. We might, but that would take away the coolness of writing it as a let. Correct? All right. So the question is here, if I'm going to create a local environment here, so I'm going to create a local environment inside of my parse Simon that governs the entire cond. So the very first thing I'm going to do in here is I'm going to start off with a let. And I'm going to create my let environment there. This is now my let body. And then all the way at the bottom, I'll close the let. Okay? So all these guys now are we'll see this guy still works. Oh, hold on. It expects a binding variable, so let me just throw something in here real quick. A5. Oh, too many parentheses. Hold on. What am I, Dane? There we go. All right. Okay. So now we have our let. What's this code doing right now? Oh, okay. I was like, why is this broken? All right, we've already started making our changes. We already changed it to a math expression. Okay. So inside this let, we want to define maybe something called is math exp to be a lambda that takes in a symbol. And it returns true if that symbol is a plus sign or a minus sign or a divide or a multiplication. Make sense? How do I do that? How would you write that function? Go ahead.
Do it recursively, comparing it to the first element in the list, and then
Okay. So really, you want this guy to take in, well, you're going to do what recursively? If you were going to make it more generic, you can do it recursively. Maybe you say, is member of list, or something like that, where you took in a list. But in this case, let's just brute force it. So in this case, we'll have an OR. And inside this OR, we'll say EQV S plus sign, EQV S minus sign, EQV S divide, EQV S multiply. Okay? I need one more. There we go. So that's what that guy is. We just OR all those together. If any one of those is true, this guy is a math expression. That make sense? Question is, can I use a let for that? So this comes down to, can we use a let star, or a let rec? I'm creating a variable named isMathExpression, and its value is an expression, a lambda expression. Under what circumstances do I need a let star over a let? So what must be true in order for me to require a let star?
you can define a variable and use it in the same expression inside.
I can define a variable in terms of other variables previously defined inside of this let. That make sense? So a let does not allow us to do that. A let star does. Am I doing that here? Well, first of all, I'm only defining one variable. So that's kind of off the list, right? All right, what does a let rec do?
In terms of themselves.
Lets us define a function in terms of itself. Am I using isMathExpression anywhere in here? Nope. So is a let good enough? Let seems good enough. So I create a little variable in here, isMathExpression. So now what we'll do is this guy right here, instead of saying EQV that, we'll say isMathExpression. Is that how I spelled it? Nope, just EXP. isMathExpression, that guy. If that's true, create a math expression. That make sense? Now let's test that to make sure that's working. So let's call parse Simon on a couple of math expressions that are beyond just plus signs. Change what?
Are you going to be applying this expression?
No, we're not going to apply it yet. We just want to make sure that it detects them as all math expressions. Yeah, his concern is that we're not actually capturing the operator. You know, a math expression, we kind of need to know about a third piece of information. So is it a plus, is it a minus, is it times, that kind of stuff. But let's just make sure that we are correctly identifying all things that have a plus sign or a minus sign or a divide or a times as math expressions. All right. So let's make sure this guy still comes up as a math expression. There's my math expression. Okay? Got that guy all right. So plus sign still works. Let's see if a minus sign works. Still a math expression. Let's see if a multiplication sign works. Still a math expression. Division. Still a math expression. That should not be a math expression, right? That treats it as a var expression because, oh, must be a variable name because I don't know what else it is. Make sense? Okay. For homework, I'm giving you like a pretty far starting point here. Given that we already have apply expression done for add expression, you don't really need to change very much to make this work for any operator. Given the starting point below, finish modifying math exp in parse Simon, and then update apply expression to work for plus, minus, times, divide based math expressions. Make sense? And there's your starting point code. And this is due Tuesday. All right, questions, comments, concerns, bribes? I'll see everybody on Tuesday.